And here we have the final video in the series, and we're looking at putting it all together. So we've talked about Ohm's law, we've talked about potential dividers, we've talked about what each of the individual components in this circuit does. So now we're going to look at the function of the entire circuit. We've got just the transistor down here, and I just want to give you a little reminder that this lead is the base, the collector and the emitter, and there has to be a voltage of 0.6 volts or more at the base to allow the current to flow from the collector to the emitter. So let's look at it in Circuit Wizard. So here's our humidity sensor circuit in Circuit Wizard. Once again, I've put in the 9 volt and the 0 volt rail rather than the battery, because I want you to remember that all 9 volts has to be used up across these resistors. Now we've actually got 3 resistors in this potential divider, but because we've only got a connector here, these 2 resistors are treated as one, because we're measuring the voltage across these 2 added together and the voltage across the bottom one. Now if you remember, the voltage across the bottom resistor is voltage out, and this voltmeter is showing that voltage. So at this point in time, the 1.2k of this resistor is using up 4.26 millivolts out of the 9 volts being put in the circuit. That means the vast majority of the voltage is actually across these 2 here. So this must have a very, very high resistance. Yep, 24k in comparison to 1.2k. Okay, this is 100 ohms. It really isn't having a huge impact on it when we're looking at thousands of ohms in the other 2. So, if we change the value of this, as we increase this resistance, the voltage across this increases, therefore the voltage across this decreases. So we're now down to 214 millivolts. But if we blow on our humidity sensor, we will reduce the resistance. And as we reduce the resistance, then the voltage goes down on the top part, so it goes up on the bottom. So this is now at 6.69 volts, which means that our transistor, which is triggered at 600 millivolts or 0.6 volts at the base, has turned on, and it's allowing the current to flow from the collector to the emitter. So our 9 volts or our battery is our power supply. Our humidity sensor is our trigger for the circuit. Its function is to reduce resistance the more humidity there is, and it is part of the potential divider. The variable resistor at the bottom, the preset, is there so that we can change the humidity level that causes the LED to turn on. Okay, so if I take this and I increase it, our voltage goes up. If I take this and I decrease it, our voltage comes down. So now we need more moisture, or a lower resistance at the top. We need more moisture to get this to turn on. So the purpose of this variable resistor here is to set the humidity level that actually triggers the LED being turned on. And it does it by changing the potential difference, the voltage, at the base here, because we've got our potential divider split in 2. This is a current limiting resistor, which is purely there to protect the base. The base of the transistor does not like a high current. So to bring the current down, we've put a resistor in, because if we increase the resistance, we reduce the current. That's Ohm's law. So that's what he's there for, current limiting resistor, to protect the base so the transistor doesn't blow up. And here we've got our LED, which will turn on when the current is allowed to flow from the collector to the emitter. So it's our output to show that the humidity level has been reached. And this is also a current limiting resistor, because LEDs don't like the current to be too high, otherwise they'll blow up. And therefore we've got a resistor here that is there to protect the LED from blowing up. Hopefully that answers the questions that you need for page 7 in your booklet.